Hello, it's Mr. Wakefield here again, coming back now with two sections in one here, section 7.2 and 7.3. We'll be looking at both of those here. And in the last video, we learned how to factor a polynomial that has 4 terms. So in this video, we'll learn how to factor a polynomial that has 3 terms, and then in the next video, 2 terms. All right. And that's what a trinomial is. Tri means 3, so trinomial means a 3-term polynomial. So how do we do it? Well, there's a lot of different ways to do it. But first of all, we need to know what kind of trinomials we're allowed to do. So let's read this thing that I wrote down up here. This is not on your worksheet already. You can go ahead and write this down if you like, or take a picture of it just to have it, just so you know. If you don't write it down, I don't mind. What's important is that you know what it says and you understand it. But let me go through it. It says if you're factoring a trinomial, 3-term polynomial, and you've already done the GCF step, okay, which remember, we always do the GCF step first, whether you're doing 4 terms or 3 terms. And also, as we'll find out, 2 terms, it's all the same. The GCF step is always first. You got to see if there's a GCF to factor out. Okay, include a negative sign with the GCF if necessary, so that this A number that I'm going to get to here in a minute down here, listed below, is positive. You want that to be positive it has to be positive in order for these steps that I'm about to show you here, in order for them to work. So that's very important. Okay, and usually that won't be an issue, but I'm just letting you know that. As I said before, though, with the GCF step, if the GCF is equal to 1 and you don't need to include a negative sign to make this, in other words, if the A is already positive, that's when you would include a negative sign, as if usually when this first term is negative, so that you could turn it into a positive A value here. Okay, so if this A value is already positive, which it usually will be, okay, and the GCF is 1, then you can skip the GCF step. And usually that will happen, but not always. Okay, I'll show you some exceptions to that coming up here, where the GCF is not 1. Okay, so you can skip this step if it is 1, and you don't need to change the value of the A to a positive. It's already positive. But if it's not, you got to do that step first. Either way, though, after you're done with that, you take the remaining trinomial. In other words, if you factor out the GCF, that thing that's inside the bracket, okay, and if you don't factor out the GCF, then the remaining trinomial is just the original problem. Either way, in order to be able to factor that thing, you can only factor it, at least in this class, okay. If you go on into Math 71, you'll see some other options, but in this class, you can only factor that remaining 3-term polynomial if it's in one of these 2 forms here. Let me explain these things here, because it doesn't always look exactly like this, but it could still mean the same thing. This is saying here that you have x squared, x to the first, and then no x at all. That doesn't mean that the variable has to be x. It could be, for example, in this first problem down here, it could be a squared, a to the first, no a at all. D squared, d to the first, no d at all. That's the kind of format we're talking about right there. So these things are the kinds of things that you could potentially factor. Okay. And it doesn't have to be pluses. The pluses could be minuses also in between the terms right here. Like you saw down here in these first few problems, we got some minuses here. Okay, that's fine. This one right here is also something you can factor. It's going to have a very similar type of method that you can use on it. And the way it works is it's x squared, a totally different variable being squared over here, we call it y squared, and then those same 2 variables are in the middle taken to the first power. Again, it doesn't have to be x and y. What's important is that you have a variable squared, a totally different variable being squared over here, and then in the middle you have those same 2 letters taken to the first power. Okay, so here's an example of that right here in problem D. A squared, b squared, and then a to the first, b to the first in the middle. Okay, that would be an example of that second possibility. So you can potentially factor this as well. So if your trinomials, which they usually will be, are in this form after you've done the GCF step, okay? If they're in this form, which they usually will be after that step, then there's, like I said, multiple different methods that you could use. The one that I like the most is called the Berry method, okay? I will also review with you two other popular methods that you may have seen in the past in a previous math class that maybe you where you learned factoring. I will review that with you due to the time that we had and time we needed to devote to talking about the Berry method. I'll just review that, but you're more than welcome to contact me office hours or Canvas inbox if you have any questions about those alternative methods, okay? Because I'm just going to kind of do a quick review of them, but wanted to let you know that those two alternative methods that I show you in a few minutes here are also okay to use, okay? You don't have to use the Berry method. In fact, after we go over all three methods, this one along with the two alternative ones, I want to make it clear you can do any one of the three, okay, for any and all problems on this 7273 worksheet, okay? You can do, in fact, I would recommend that you pick one that you like the most and just stick with it, but you don't have to learn all three methods. I want to make that clear. You can pick the one you like the best and stick with it, just so long as you can do all the problems in the 7.2 and 7.3 worksheets, okay? There's a couple of sheets here for that. Then that's fine. You can stick with one method. All right, so I wanted to make that clear. Let me know if you have any questions about that. But we're going to look at the Berry method primarily here, but I'll also, like I promised, look at the two alternative methods after we do the first 5 problems right here. So let's talk about the Berry method. Okay, I have a bunch of steps here for that, but the easiest way to teach it to you is to actually show it to you in the actual examples, but you can always refer back to these directions as well. Okay, let's jump into the first problem. Again, the GCF is equal to 1 right here. And since that first coefficient is already positive, you don't need to do anything with that either. Remember, it has to be positive after you do the GCF step. It already is. And since the GCF is 1, you don't need to factor it out. Okay, again, if it's not 1, that's different. You'd have to factor it out. We'll see that actually in problem C right here. I'll show you how to do that. So, we can skip the GCF step, and then here's how it works. What you do in the Berry method is you take the first coefficient and the last coefficient, not the middle one, not yet, and you multiply those together, okay? And that gives you 90, doesn't it? 5 times 18 is equal to 90. Okay, that's a key number right here. Here's what we're going to do with 90. I want you to list out all the factors of 90, okay? At least list out all the ones until you find the pair that works, all right? What do I mean by the pair that works? You need to find a pair of factors of 90 that add up to negative 21, okay? Now, this could include negative numbers, okay? Normally when we list out factors, we list out just positives, but we're going to include negatives here in some cases when necessary. Remember, you guys, that when, and it mentions this right here, all right, since the A part is already going to be positive, the C is going to tell you what's going on with the with this number right here. When the C is positive, which means that this number right here will be positive, okay, both factors, in other words, both pairs of numbers that you're going to pick have to be the same sign as the middle coefficient. All right. Let me start listing out some factors, and then you'll see what I mean here. 1 pairs up with 90, right? 2, that works. It pairs up. 90 divided by 2 is 45. If you put that in your calculator, if you didn't know that already, you can do that. 3 pairs up with 30. Okay, and you can just keep on going with this. But here's the problem, though. It has to equal positive 90. When these are multiplied together, I mean, when these pairs of factors are multiplied together, that has to equal positive 90, and they do. But they have to also at the same time add up to negative 21. You need to find a pair here that adds up to negative 21. That's never going to happen with these because they're both positive. But it's also true, you guys, and this is what's going to help you. It's also true that when you have a positive answer, you could also have two negatives, can't you? Because negative times negative is also positive. So here's my point here, you guys. When this number right here is positive, you either got to do positive positive or negative negative. All right? Because that's the only way it could equal positive when you multiply it. All right? So I'm going to do this right here. I'm going to make this negative negative because that's the only way that it's going to add up to negative 21. It's no use trying to do 1 and 90 and 2 and 45 if they're both positive because there's no way it could ever add up to a negative. But two negatives could add up to a negative. They could do that. None of these add up to negative 21, but if we keep going, all right, maybe we'll find a pair that does. Let's keep going here. What's the next one here? It would be 4 is not going to work. 90 divided by 4, that doesn't work. But how about 5? 5 pairs up with 18. If we make both of those negative because we know the positives won't work, then that would be negative 23. That's pretty close, but not quite. So let's keep going here. Maybe we'll eventually find it here. We're getting closer, though, it looks like. How about negative 6? In other words, 6, but we're going to make a negative. 6 pairs up with 15 because 90 divided by 6 is 15. Remember we talked about in the first part of 7.1 how to make your list of factors here. Go back and look at that if you need to. But I'm just doing 1, 2, 3, 4, 5, 6 and seeing what works and then putting the corresponding partner to those numbers on the other side. But anyway, these two numbers add up to negative 21, don't they? Okay, we found the one. So that's what you do. You keep on making pairs of factors until you find one that works for the middle number there. We did it, okay? So they got to equal 90 when you multiply them together, but they also have to add up to negative 21 when you, I'm sorry, I said that wrong. I apologize. They need to equal 90 when you multiply them together, okay? But they need to add up to the middle number. Okay, so they got to equal this when you multiply, but they got to equal this when you add. Okay, all right, don't worry. If you're still trying to get used to that, we'll have plenty more opportunities to practice this here. All right, now, once we figure out what those two numbers are, here's what we do. We got just 2 more steps to go here. If this is 5a squared right here, then you're going to do 5a and 5a. No, that does not equal 5a squared, but this is a little trick that's going to get you to the answer. Okay, if I were to multiply out these two brackets, it would not equal 5a squared. I understand that. Okay, but it's going to get us to something that will equal 5a squared, I promise you. Okay, what you do after this, it's just all a part of the Berry method, all right? It gets us to the answer in kind of a strange way, but it's a good way. What you do then is you take these two numbers, and let me back up for just one moment. Just to make sure you understand, if this had been 3a squared, we would do 3a and 3a. If this had been 8a squared, we would do 8a and 8a. Okay, just to make sure you understand how I did that. But what you do now is you take these two numbers you found and you go like this. You just take them and you put them behind the 5a and the 5a. That's not the final answer, but we're almost there. One more step to go. Okay, and then we'll have it. Now, what you do is you look at your two brackets and you actually factor out the GCF out of each bracket individually. But the difference is that when you factor it out, if there is one to factor out, then you actually get rid of it. Normally when you factor out a GCF, you got to put it in the front and all that. In the last step of the Berry method, it's different. When you factor out the GCF, you actually take the GCF you factored out and you just throw it away. You don't keep it in the answer. Let me show you what I mean. What is the GCF of 5a minus 6? Just looking at that only, not the other part, but just 5a minus 6. The GCF would be 1, right? If your GCF is 1 on the last step of the Berry method, Again, you don't have to factor that out. Okay, because if I do factor it out, it's not going to change the 5a minus 6. Anytime you factor out 1, what you started with will be the same thing as what you ended with. It'll still be 5a minus 6. Okay, but the second bracket, that has a GCF that's bigger than 1. Isn't it equal to 5? Okay, if I factored out 5, you don't have to write this down, but just so you can see what I'm thinking. Okay, if I factor out the 5 out of that, it's going to be 5a minus 3. So here's how it works, you guys. Again, the 5a minus 6 doesn't change because the GCF was 1. What's going to happen with this, since it's the last step of the Berry method, normally we would keep this 5 here, but not in the last step of the Berry method. What you do instead is you just keep the bracket that you just created, the a minus 3. So the 5 is basically going to go away. Again, normally you don't get rid of the GCF, but just in the last step of the Berry method, you do. And that's it, you guys, okay? We created our two brackets, all right? When you're factoring a trinomial, there's two things you got to do, okay? You have to factor out the GCF if there's one at the beginning of the problem. That's the first step, as always. And then you got to try to create your two brackets if you're able to. And we'll see an example when you can't later, and I'll go through that carefully. But you can create two brackets here. So my point is that once you've done that, and you've done that step where you factor out the GCF out of each bracket, the last step of the Berry method, then the two brackets you have left over, that's the final answer, no doubt about it. Okay, so when you're doing three terms, you just have to do those two things, the GCF in the original problem, and then create the two brackets. Okay, let's go ahead and try that again now. It's going to be a little bit different this time, as you'll see, but a lot of stuff that's similar as well. So you're going to start to get used to this now. Don't worry. Okay, problem B. The GCF of the whole problem is 1 again, so you can skip that step. In problem C, it will not be, so we'll see how to handle that, okay? Then what you do is you go 12 times negative 5. The first coefficient times the last coefficient, just like in the previous problem. What is 12 times negative 5? That is negative 60. Negative 60. All right. The way we do negative, see, this one over here was positive 90. This one's negative 60. When it's positive, you're either going to have positive positive on your pair, or you're going to have negative negative, and it's dependent upon what's in the middle. So if this had been plus 21, you would have done positive positive instead of negative negative. However, negatives here on the top are different. Okay. You just have to, here, I'll show you what I mean. The first pair of factors is going to be 1 and 60, right? So what you got to do is a little bit different. You guys know that when you do negative times positive, that's equal to negative, right? But you also know that positive times negative is also negative, all right? So you need to look at both of those, because either one of them could potentially be equal to this in the middle. So you're just going to have to do both in this case normally. Whereas over here, it was dependent upon the sign in the middle, either positive, positive, or negative, negative. In this case, it was negative, so we're going to do negative, negative. But when this number on top is negative, though, instead of positive like 90 was, then you're just going to have to do both. You're going to have to do, you're going to have to do negative, positive, and then positive, negative for each pair. Do either one of these pairs add up to negative 28 in the middle like they're supposed to? No, they don't. So then we go to the next pair. For 60, it's going to be 2 and 30. 2 and 30 would be the next pair. So this is what I do. I go negative 2, positive 30, and positive 2, negative 30. Do either one of those pairs add up to negative 28? Well, good news. This one does. And so again, you just have to keep on going, okay, until you find a pair that works. If no pair works and you've listed out every single different possibility, that's a different story, and I will get to a problem that explains that coming up. Don't worry about that. And we'll learn about how to handle that, okay? But otherwise, you just need to keep going until you find a pair that works. Okay, so now we're going to do exactly the same thing. that we did in the last problem. Okay, we write down our two brackets, just like in the last problem. And then since this is 12d squared, we're going to do 12d and 12d. Okay, just like 5a squared was 5a and 5a. 12d squared is 12d and 12d. In other words, you just write down the same term, but you don't put the exponent 2 in there. Okay, so it's just like the 2 is disappearing, otherwise it's staying the same. Then what you do is, since you have positive 2 and minus 30, when one of these is positive, you have to say plus, okay? You can't just write 2. So if it's positive, you got to say plus if it's the second term here behind the 12d, okay? Since the minus 30 is negative, I'll just say minus 30 like normal, okay? And so what's the last step of the Berry method after I set up these initial two brackets? The same thing as it was over here. All right, you factor out the GCF out of each bracket. Let's start out with the first one, 12d plus 2. Again, you don't have to write this down, but I just want you to see what I'm thinking. If you factor out the GCF out of that, you're going to get 2 times 6d plus 1. That's just the first one here. So what you do is you get rid of the 2, because this is the last step of the Berry method. That's when you get rid of those GCFs that you factor out. And you just keep the bracket 6d plus 1. Okay? You do the same thing with 12d minus 30. What is 12d minus 30 going to be if I factor out the GCF? Well, the GCF is going to be 6 right there. And so that's going to be 2d minus 5. 2d minus 5. So again, because of the step that we're on here, we discard the 6 and we just keep the 2d minus 5. And I guarantee you guys, if you multiply these two brackets together, just like we learned how to multiply brackets together back in section 6.3, first day of class, all right, then I promise you it's going to end up being equal to this. It really is equal to that, but we factored it down to these two brackets here, all right. By the way, what does the word factor officially mean? It has multiple definitions depending on how you're looking at it. But factors are things that are multiplied together. You see how we took one polynomial and broke it down to these two smaller polynomials that are getting multiplied together? We know they're being multiplied because the brackets are right next to each other. That's what factoring a polynomial is about. You're taking one big polynomial, you're breaking it down to two smaller ones. Okay. Sometimes that involves just having a GCF term on the outside being multiplied by a bracket. But even in that case, you guys, even in a case like that, you're still breaking down one polynomial. Like back in 7.1, you're breaking down one polynomial into two things being multiplied together. The GCF times the bracket. So that's what factoring is about. You're breaking it down to one thing being broken down to two things being multiplied together. Although, as we'll see here in the next problem, sometimes it could be three things by the time you're done. Okay, and don't worry, we'll go over that carefully as well. All right, so, but that's what factoring is about, breaking it down to smaller things being multiplied together. Anyway, in this next problem, there actually is a GCF bigger than 1. What is it? And since it is bigger than 1, we have to do it. We can't skip it in this case. As it turns out, see how the smaller number there is 18? Smallest number out of the three coefficients. Which one is going to work here? Well, the 18 doesn't work. The 9 doesn't work. And 9 works for 45, but it doesn't work for 57. The 6 does not work, but the 3 does. So that must mean that 3 is the GCF. Don't put the Q in there because the Q is not in all the terms. Remember, you don't put a variable in a GCF unless it's in all the terms, that same letter. So what do we get when we factor out the 3? We get 15Q squared plus 19Q. 3 times 19 is 57. And then plus 6. Okay, now here's the thing, you guys. Since we factored out the GCF, you now take the leftover or the remaining trinomial and you try to factor that. Okay, you don't go back to the original problem and try to do 45 times 18 like we did in the last few problems. You still do a similar technique as the last couple problems, but you do it on just the remaining trinomial, which is the 15 and the 6, not the 45 and the 18. That's how you have to do it. So if you do end up factoring a GCF out of the original problem, okay, you only then try to factor the remaining part, not the original part up here with the 45 and the 18, but instead the 15 and the 6. Okay? What is 15 times 6? 15 times 6, again, is 90, just like the first problem, but this one's going to be different because the middle number is positive this time. It's positive 19. Remember what we said, if this number is positive, then it's either going to be negative negative on your pairs, or it's going to be positive positive on your pairs. It all depends on the middle. Okay, since the middle is positive 19, then it wouldn't work. Let me go back over here to show you. None of these pairs for 90 would add up to positive 19, because negative plus negative is always a negative. Remember, negative times negative is positive, but negative plus negative is always negative. So none of these would work. None of these would have any chance at all of equaling 19, because 19 is positive. So what you got to do when this number at the top is positive, okay, but the middle number is also positive, is that you have to do positive times positive here. It's the same pair of numbers as the first problem because it's still 90, but you're just doing different signs here. Okay, but since it's still 90, you're still doing the same basic factors here, but just different signs. None of these add up to 19 yet, do they? Okay, we're getting closer though. 6 plus 15 is 21. Okay, 7 doesn't work. The next number would be 8. That doesn't work. But 9 pairs up with 10, doesn't it? Oh, hey, 9 plus 10 is 19, though, right? So again, we keep on going. We keep on going on this list here until we find a pair that adds up to the middle. Okay? Now, here's what you do. First of all, it's very important, you guys, that when you factor a GCF out of the original problem, you have to keep on bringing it down into the answer. Okay? You can't just forget about it. It's different than that last step of the Berry method where you can just get rid of it. The original GCF has to be kept all the way through the problem. You've got to keep on bringing it down, and it's got to be in the answer. Okay, so just keep on bringing it down so it stays in the front. You'll be fine. Okay, and then let's figure out the rest of it here. And so what we need to do, just like in the last couple problems, is we take, since the first term there is 15q squared, not 45q squared, but we're just going off of the remaining trinomial, 15q squared, that means we do 15q and 15q, like that. Okay? And then we take these two numbers, and since they're both positive, we need to put pluses in front of them, just like we did with the plus 2 on the last problem. Okay, so plus 9 and plus 10. Does it matter what order you put it in? No, it does not. Not in this step. You could put the plus 10 here and the plus 9 here. It's still going to give you the same two brackets. And as we mentioned in the last video, if you have two brackets being multiplied together, as long as they're the same two brackets, it doesn't matter which one goes first. It doesn't. Okay. The order doesn't matter when you're multiplying two things together. It's still the same thing. And then we need to do that thing where we factor out the GCF out of each bracket, the last step of the Berry method. So for 15q plus 9, if I factor out the GCF, which is 3, I'm going to get what? I'm going to get 5q plus 3. All right. Sorry, that came off the page there. There we go. And then the other one, if I factor out the GCF out of that, that's going to be 5. And so that would be, when I factor it out, 3q, not 2q, 3q plus 2. Like that. So again, with the last step of the Berry method, you get rid of the 3 and the 5. You don't get rid of this 3, though. That's the original GCF. Remember, we got to keep that. We just get rid of the new GCFs we created on this last step. And we keep the brackets, just like we've been doing, okay, in the last couple problems. This one's the same, like that, okay? There you go. All right. So don't forget to look for the GCF. If it's not equal to 1, you got to factor it out. And then since it's the original GCF, you got to keep it and bring it all the way down to the answer here. Okay. Let's keep going here. This next problem is different because it's that one where you got the two different variables. But thankfully, the way you do the Berry method, although it's slightly different, it's almost completely identical. So that's nice. Okay, but I'll be careful to point out the differences. Okay. Again, the GCF is 1 here. So we can skip that step. All right. And then we take the first coefficient and the last coefficient. 5 times 12 is equal to 60. Since 60 is positive, then just like with positive 90, we either are going to do negative negative or positive positive. And it's all dependent upon the middle here. Since the middle is positive 23, then we're going to do positive pairs of factors here. So just like we learned with this negative 60 over here, all right, with the 60, you're going to have 1 and 60, 2 and 30, and so on, so on, so on. Okay, but it's got to be positive, positive. Otherwise, it'll never add up to positive 23. You could write down negative 1, negative 60 also, as long as you write down positive 1, positive 60. Okay, it's just that you'd be wasting your time because there's no way that negative 1 and negative 60 could ever add up to a positive. All right. So I'm just trying to help you get to the answer as quick as possible here by giving you these little hints here about how to set up your pairs of factors. Okay. Since this is positive, we're just going to do 1 and 60 positive, 2 and 30, both of them positive. Do either one of these pairs add up to 23? No, not yet. Okay. Then we go to the next one, which is 3 and 20. Oh, hey, that adds up to 23, doesn't it? So again, you keep on going until you find the right pair. All right, if there is one. Now here's what's going to be different, though. Just slightly different, though, thankfully. The first part is the same, though. Remember we said that if it's 5a squared, that the first terms are going to be 5a and 5a, right? Okay. The difference is that when you do the 3 and the 20, you guys, because it is b squared on the back here, instead of just being just a constant number like the other 3 problems were, you didn't have any variables on the back here, because this has b squared on the back, you're not just going to say plus 3 and plus 20. That is part of what you're going to say. Okay. Instead of just saying plus 3 and plus 20, see how I left some space right there? Okay. We're going to also put what in there? We're going to put a b in there. Okay. So if there's a b squared there, you need to put a b next to each number for the second term in each bracket here. If that had been y squared, you would put a y and a y in those 2 spots right there, right behind the number that you put there. So you do the same thing you normally do with the plus 3 and the plus 20. You just got to put that variable in there. But remember, just like with the a, you guys, it's b to the first power and b to the first power when you put it in there. Okay, so don't include the exponent. Just say b to the first and b to the first. Okay, but you got to do that second variable there when you have this second variable in the original problem, the a squared and then the b squared. All right, unlike these problems up here where it was just a squared, a, and then no variable at all. That's different. Okay, but when you got 2 different variables, you got to do that. Then we do the last step of the Berry method. The GCF for the first bracket here is 1, so you can skip that. It's not going to change anything if you try to factor out a 1. Okay. What's the GCF on that second one, though? That's 5. And so if I factor that out, I get a plus 4b. So as you guys now know, in the last step of the Berry method, you then discard the new GCF you factored out there, and you just keep the remaining bracket. And there you go. Okay? And so that's really the only major difference when you got the 2 different variables here on each end, is to remember that variable in the back. in the back part of each bracket. Okay? Last one here, and then I'll let you guys try some. And I'll also talk about quickly those other two methods that you could potentially do if you don't like the Berry method. Okay? The GCF here is going to be 1, so we can skip that step. First and last coefficient, 6 times 3 is going to be 18, right? It's always nice when you have smaller numbers, okay? Usually easier to deal with. Since that's positive 18, again, it's the middle number that tells you what the signs are going to be for your pairs of factors. Since it's 10, okay, then we are going to do, I'm sorry, it's not 10, it's negative 10. Since it's negative 10, we're going to do negative negative. Just like over here, we did negative negative because it was a positive number at the top, but the middle number was negative. So we got negative 1 and negative 18. Normally it would be 1 and 18, but we got to make them negative. The next one is negative 2 and negative 9. Still nothing adds up to negative 10. Next one is negative 3 and negative 6. Still doesn't add up to negative 10. 4 doesn't work for 18. 5 doesn't work for 18. And then the next number is already a number that we have on the other side, the 6. And so that means that this is the entire complete list. But we got a problem here. We've made the entire list and nothing works. What does that mean? Here's what it means. When there is a GCF of 1 in the original problem, you guys, which it was, and you are not able to break it down to 2 brackets, and in the case of the Berry method, you know that you can't produce 2 brackets if you are not able to find a pair over here. If you've looked at all the different pairs and nothing works, then that means you can't produce the 2 brackets. Okay? Anytime, you guys, anytime at all, that it doesn't matter how many terms you have in the original problem, whether it's this section or section 7.1 or 7.4, whatever it may be, anytime they ask you to factor a polynomial, if the GCF is 1 and you cannot produce the 2 brackets after that, that means that you can't factor it at all. And we have a name for that. It's called prime. That's all you got to say for your answer. Just got to circle the word prime. Okay, always circle your answer. So we're circling the word prime. And that's what happens when, again, the GCF is 1, and then you're not able to break it down to 2 brackets. And in the case of the Berry method, we know that 2 brackets are not possible, again, when none of these pairs of factors that you're writing down are going to work. Okay, so what I have now are 9 additional problems, 9 of them because practice is so important here in these problems, okay? But before I get into that, as I promised you, let's take a look at, not that, let me get to it here. Actually, it's over here, excuse me. Here we go. Please ignore the A, B, and C right here. This is a totally different worksheet. And this one right here is an example of the grouping method, which is listed, the steps to that is listed on the back of the second page of your current worksheet, not this sheet here. This is a separate sheet. But the steps are listed on the back there. I'm just going to go over these problems here with you. You can take, again, a picture of this so that you have it with you if you really want to try this method. What it is because I'm not going to go through these things one step at a time, I'm just going to kind of skim over this here. Again, like I said, let me know if you have any questions about it. These are the same 3 problems that we just did in, it was problem D, pardon me, it was problem B, C, and D on the worksheet that we just did. Okay, yeah, that's what it is. So this was problem B, this was problem C, and this was problem D. Okay, same exact problems, and you can see the answers come out exactly the same as the way that they did on the front. Yeah, there's the answer up there. I had to put it up there while I was running out of room. But yeah, you can see that's the same answer. Same answer here as well as it was in problem D. Okay. And so let's go over this method though. The way you start the problem is exactly the same. After you do the GCF step, you multiply the first and last. You pick the appropriate pair, exactly the same as it was in problem B. The difference, though, is instead of doing the two brackets and putting the 12D and the 12D in there, what you do is you take the middle term. You got to keep the variable part of the term the same. So if it's d to the first, you've got to do d to the first and d to the first. But what you're doing is you are expanding the middle term here into two brand new terms. The first and last term are going to stay the same. They're going to stay in their same spot, first and last. But the middle term expands out into two brand new terms in the middle. You still do a plus if it's positive. You still do a minus if it's negative. And again, it does not matter what order you put these in. You could have said minus 30D plus 2D, okay? And then what you do is you then realize that, hey, I now have 4 terms. That means I could do factor by grouping from section 7.1. So I then did that right here, and I got exactly the same answer. Okay, and so that's called the grouping method because it becomes a factor by grouping problem. All right, same thing happened here. The only difference is that you just got to remember to put the 3 in the answer, because when you're in the process of doing all this other work here where you expand the middle term and everything, okay, after you find out that 9 and 10 are going to be your 2 numbers, okay, you put the 9q and the 10q in the middle. All right, again, it's got to be q to the first and q to the first because the middle was q to the first. It's got to be the same. All right, but after you do all that work, you just got to remember to put the 3 in the answer, okay, in the front, because it was the original GCF. So you can see there's some similarities here. In this last one here, again, remember that since the variable part of the term, after you find the 3 and the 20, okay, the variable part of the term is AB. And so it still has to be AB. Okay, so you got plus 3AB and plus 20AB. All right. So you can see that there's definitely differences here. When we did the problem on the Berry method, it was 3B and 20B. Okay, but if you do the grouping method after this, you see that we end up with the same exact answer in the end, even though in the middle of the problem there's definitely some differences. Okay, it's a different method, different stuff going on in the middle of the problem, but then you end up with the same correct answer. All right, so that's the grouping method. Okay, as far as the trial and error method is concerned, let's take a look at some examples there. I'm going to look at this second example here because that's a problem that we already did both in the Berry method, and we also looked at it with the grouping method. We do the same thing to start out in the trial and error method, where we find these 2 numbers that equal negative 60, but they add up to negative 28. We do that same thing to start. And then just like we did in the grouping method, only I wrote it in a vertical format here instead of writing it across like you do when you write a polynomial. But it's the same 4 terms. I didn't put the plus in front of the 2 because it's not written in the normal polynomial way going across. But otherwise it's the same thing. Okay, and we take those 4 terms. And don't worry about the first and last term. Those are already, just like with the grouping method, those are already there. But what you need to do at this point in order to get this same answer is the following. You need to take the first term, I brought it over here, not just the 12 this time though, but the whole thing, the 12d squared. And because the d squared is included, when you make the list of factors for 12d squared, you don't just do it 1 and 12 and 2 and 6. You do 1d to 12d. In other words, you put the variable in there. Again, no exponent, but just the variable, d and d, d and d, d and d. And if it had been x squared, you go x and x, x and x, and so on. D should only be positive, all right? No doing negative, negative, or anything like that there. Not with the first term. But you remember to put the variables in there. So you make that list. I'll get to why we do that in a minute. Then when you get down to the last term here, you make a list for that as well. And the rules for how you make that list as far as the signs are concerned are the same as they were for the Berry method, where if it's negative, then you do positive, negative, negative, positive. If it was positive, like you'll see over in, say, this problem over here, where it's positive 6 on the last term right there, then it's based on what's in the middle. Okay, if it's plus in the middle, then it's positive, 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 positive. Just the same thing as it was before with the Berry method and the grouping method actually as well. So that's how you make that list. Okay, right here. Then what you do is you pick, and we're just focusing on the two middle terms here. These first two terms are already established. Okay, you don't need to do anything with that right now. But you take those two middle terms, and what I want you to do is I want you to pick one term from this list. It could be any one of these 6, and then you pick one term from this list. So again, one term from this list, one of these 4 terms from this list, and you pair them up so that they equal 2D when you multiply them together. Wouldn't these two work right here? Okay. And if you can't find any that work, one from this list and one from this list, then that's one of those problems that's going to be, actually, you'll know that even beforehand. Okay. You'll know even beforehand that it's prime because you won't be able to, find, just like we talked about with the Berry method, you wouldn't be able to find something that adds up to the middle number. Okay, so you wouldn't even get this far with that. But so you should be able to find a pair if you make it this far where you're able to find the two numbers and everything. You should definitely be able to find a pair, one from here, one from here. And then once you find one for the 2D, you then find one for the negative 30D, and it should be the same pairs that it comes from. So since the 2D goes with the 6D and the 1 goes with the negative 5, that means that the 6D and the negative 5 should automatically equal negative 30. If you did it correctly, that should happen every time. Okay, so find a pair that equals 2D when you multiply them together. Again, it's got to be, I can't say it enough, it's got to be one from here and one from here. It can't be like 2 of them from the same list. One from here, and then pair up the same things that were matched up with the 2D and the 1, and they should also work for the other one. Okay, we're almost there. Now, what you do at that point is, let's pretend like we don't know what the answer is yet. Let's pretend like we're doing the problem up here just so you can see how you go about it. What you do is you take these two things right here, and as we learned back in section 6.3 in the first day of class, these things right here, because they equal 12D squared, let me just say it this way, it'll be easier. These two things right here do equal 12D squared. So since they're the first term, okay, those are going to be the first term in each bracket. So whatever two things that go together in this first list that you circled, they're going to go in the first spots. And then whatever you circled here from the second list, because it's the second list, it's going to go in the second spot of each bracket. But here's where you got to be careful. Okay, you can't just put it in any order you want. Okay, since you're doing these two terms first, it doesn't matter what order you put them in because the other terms aren't in there yet. Okay, so you could put these in either order here. But when you get to these, because you're doing these second, you got to remember, as we learned back in 6.3, that in order to get the 2D, we had to do what? We had to do 2D times 1, right? Since those are being multiplied together to equal 2D, you have to put them in a separate bracket. We learned in section 6.3 that you can't multiply terms by other terms in the same bracket. When you have a bracket times bracket problem like this, okay, you don't multiply two terms that are in the same bracket. So since the 2D is being multiplied by 6D, they got to be in separate brackets, as we already did. But then since 2D is also being multiplied by 1 to get this right here, we got to put those in separate. We got to put those two things in separate brackets as well. That's why the 1 has to go. It has to be separated from the 2D in a separate bracket as well. So that's how I know the 1 goes here and not here. So also it's true that since 6d is being multiplied by -5 to get the -30d, you got to put that in a separate bracket from where the 6d is. Again, these two things right here have to be in a separate bracket. Okay, so and then if you and again, you can see that we've got the answer now. You don't need to do that thing where you factor out the GCF. Okay, that's a Berry method thing. All right, once you get the two brackets using this method, you should be done. There's no additional step. If you got the two terms in each bracket, you should be fine. All right, and so that's basically how it's done with the trial and error method. Just a couple other notes. When you're doing that thing where you got a GCF at the beginning of the problem, again, don't forget to bring it down into the answer. Okay. Otherwise, you do the same things that I've been talking about here. See how I identified the different things we're going to use. All right. Since it's 9 and 10, that means that we need to find something that equals 9 when we multiply it. That's why I picked 3Q and 3 right here. Okay, one term from each list. And then automatically the two terms that match up with the 3Q and the 3, which is the 5Q and the 2 right here, that automatically should equal 10 when you multiply it, and it does. Okay, but it should. All right, I checked it just to make sure, but it should. And so same thing as the last problem here, but just remember to put that GCF in front of the problem there. One additional thing on the trial and error, if you're doing it this way, when you got one of these problems where you got the second variable on the back here, just remember that when you do the second list right here, it's not just for 12, it's for 12b squared. And so you're not going to have something like this right here like we did with -5, where it's just numbers and no variables. Because you got the b squared here, remember to put those b's in there. Okay, and then that will tell you what to put in there. And again, you can see I circled the ones that I picked to put in there. Okay, and that is the trial and error method. Okay, so let me know if you have any questions about these alternative methods, if you want to use one of them, since we kind of skimmed through it a little bit quickly here. But like I said, you're more than welcome to pick one of these three methods we've talked about today and stick with it. You don't need to learn all three. Okay, so again, let me know if you have any questions. So go ahead and try problems 1 through 9. And now that I have looked at all three methods, I will let you choose which method you'd like to do. And you can go ahead and you can do that on all 9 problems. You could do a little bit of one method and a little bit of another on some problems. What I mean is you could do some problems with one method and some problems with another. Okay, I would recommend you stick with one method because it's easier, I think, but I'll leave that up to you. What's important is that you, at the end of the day here, you know how to do all these problems with whichever method or methods that you have decided that you want to use on a regular basis, okay, moving forward. Go ahead and try those 9 problems. Hit the play button, and I'll show you the answers. And then I'll be doing the answers in the Berry method, but again, they should come out the same, okay, no matter which of the 3 methods you use. Okay, let's take a look at these answers here. First of all, there's actually only 8 problems instead of 9. I just realized on the back side, or on the second page there, there was a duplicate. Number 8 is the same thing as number 4. So obviously you don't have to do the same problem twice. You can skip number 8 because it's the same as number 4. I apologize for any confusion that caused. As far as problems 1 and 2 as well, notice that there's no coefficient that's visible in front. That means that it's 1. I know we hadn't seen a problem like that before, so okay. But yeah, it's just 1. And so you do 1 times 20 right here and 1 times 8 right here. So anyway, let's start to see how these things are coming out here. We end up getting 4 and 5 as the pair that we find. Because this is 1a squared, this would be 1a and 1a. And since the coefficient's 1 with the variable next to it, you don't need to write the 1. Okay. Inside it, you can just say a and a. Although you can also say 1a and 1a. That's not wrong, as I've said before. It's never wrong to write the coefficient when it's equal to 1. We then put the 4 and the 5 in there. I wrote it in a different order for some reason, but it doesn't matter because, again, because the A and the A are the same, you would end up with the same two brackets no matter what order you put the 4 and the 5 in. Okay, on that step right there where these two are the same, A and A. Okay, so if you said, as I mentioned in the grouping section 7.1, the order of the brackets doesn't matter as long as they're the same two brackets. So if you said A plus 4 times A plus 5, you're fine. Okay, no problem at all. This next one here, we end up getting -2 and -4. All right, are going to add up to -6 in the middle, but they equal 8 when you multiply them. And so we end up getting y minus 2 and y minus 4. You put 1y and 1y in the front. -2 and -4, as it tells us here, they go in the back. And the reason why I circled it, just like this one over here, is because the two brackets both have a GCF of 1. And so if you try to do the last step of the Berry method, it's not going to change the answer. It'll still be the same answer. And that's why I just circled it right away. Okay, but yeah, you do need to do the last step of the Berry method. You need to at least check to see if there's a GCF other than 1 that can be factored out. Because if there is, then you got to do it. Otherwise, it'll be the wrong answer. And we'll see that here, in fact. So here we have -30. And we end up getting, it's a little bit of a longer one here, but we eventually find -5 and 6 equal -30, but they also add up to +1 in the middle here, +1 in the middle. So we put the 15m and the 15m in there, put the -5 and the +6 in there as well in their appropriate spots, and then we factor out the GCF out of each one of these. All right, again, the first bracket, the 5 is the GCF there, so if we factor that out, we get 5 3m minus 1. But as we talked about on the last step of the Berry method, we keep the bracket and we get rid of the GCFs that we just created. Same thing with 15m plus 6. 3 is the GCF there on this second bracket up here. And so if we factor out the 3, we get 5m plus 2. Again, the GCF gets discarded, and we just keep the bracket, and there's your final answer boxed in right there. All right. On the next page there, number 4. Again, that's the same thing as number 8. So you can skip number 8 for that reason. All right. There we go. And so what is number 4? 3 times, again, the GCF is equal to 1 here on the original problem, so you can skip that step. But then we get 3 times 8 is 24. -2 and -12 were the numbers that on the list there that add up to -14. Okay. And so we put the 3x and the 3x, and these two numbers, we put all that stuff in there. We then factor out the GCFs. The first bracket did not have a GCF other than 1 to factor out, so it doesn't change. This one, when we factor out 3, we get x minus 4. Number 5. Number 5 has a GCF other than 1, so we need to do it. Okay, and when we did, notice the original problem, it's not one of the types of trinomials that we're even allowed to factor, according to what I wrote on the first page. Okay, it's not one of these ones, in other words, here. But remember what I said. It's after you do the GCF step, which I haven't done yet. That's when you consider what type of form it is. Okay, so the fact that it's not currently in the correct form, one of these two forms, that's not important because you haven't done the GCF yet. Once you do the GCF, then look at the remaining trinomial. If it's now in one of these two forms, which it is, because it's z squared, z to the first, and no z at all, same thing as this one here, now it's okay to try to factor it. If it was still not in one of these two forms, even after you did the GCF step, that would be different. Okay, and I'm not going to ask you to factor a trinomial that's like that. I'm just telling you that for future reference. All right. Anyway, we take what's left over. We do the 8 times the -3, -24. We end up getting this pair right here. We put it in there along with the 8z and the 8z. Again, you're just building off of the remaining trinomial, not the original one, when you have a GCF to factor out there at the beginning. So 8z and 8z, you put these numbers in there with it, and then you factor out the GCF out of the second bracket. There was not a GCF. In other words, the GCF was 1 on the first bracket, so it doesn't change in that case. Why is this one prime over here? It's because when we do 4 times 10 equal to 40, no pair of factors, and I only did positive because the middle was positive. Okay, again, when this is a positive number, not a negative number, the negative number you got to do the negative positive and the positive negative for each pair. But when it's positive on the top, that's when the middle determines what the signs are. So I did only positives, but none of these add up to 3, do they? None of these pairs do. This adds up to 13. This adds up to 14, 22, 40. None of them add up to 3. And so nothing works. And so therefore, because the GCF was 1 in the original problem, and because we couldn't produce the 2 brackets after that, like we normally do, then that means that it is prime. Okay? Remember, if GCF is 1 in the original problem and you can't produce the 2 brackets, that's when it's prime. Okay. Number 7. Number 7, we had 4 times 3 is 12. Again, the GCF was 1, so I moved on from that. 12, in order to add up to 8, we get 2 and 6. Put those things in there right there. We then factor the GCF out of each bracket like we always do on the last step of the Berry method. Factor a 2 out of the first one, and you factor a 2 out of the second one as well. And these are the 2 correct brackets. Final answer. And finally, number 9, since number 8 we skipped. Number 9, it has a GCF other than 1, so we have to do it. That's not an optional thing. Okay, factor that out if it's not 1. And then we're left with this. So we build off of this, not off of the 24 and the negative 4. No, we build off of the 12 and the negative 2. That gives me negative 24, but it has to add up to positive 5. And these are the 2 numbers that will add up to positive 5 off of that list. So we do our normal thing. Don't forget to bring your GCF, if it's the original GCF, that is, from the original problem. Don't forget that that should keep on coming down so that it ends up in your answer. Don't forget about it. And then do your normal thing here, 12A and 12A. Put the 2 numbers in there. And then remember to factor out the GCF if it's not equal to 1 out of each of these 2 brackets. And these are the 2 brackets that you end up with in the end. 3a minus 2 there on the last one. Okay? So that is how you factor a trinomial. Okay, a 3-term polynomial. In the next section, we will look at how to factor 2 terms. And also we'll kind of summarize all of the different factoring at that time as well. But we still need to do the 2 terms, so that'll be the big part of that next section right there, 7.4. So I'll see you for that video before that time. In the meantime, in other words, let me know if you have any questions as usual, and have a good day. We'll see you for the next video.